This video is for section 8.1. Our objectives in this section are to solve quadratic equations using the square root property and solve quadratic equations by completing the square. So back in section 5.7 we talked about solving quadratic equations by factoring. In this chapter we're going to look at a few more other methods for solving quadratic equations, starting with using the square root property. So the square root property says that if I have an equation that looks like this, u squared equals some number, then I can take the square root of both sides. So square root here, but it's not just the square root of d, it's plus or minus the square root of d. So for example, going back to what we saw back in chapter 7, if u squared equals 25, then u equals plus or minus the square root of 25, or in other words, plus or minus 5. Positive 5 or negative 5. That's what the plus or minus symbol means. So 5 squared equals 25, negative 5 squared equals 25. And so both of those are solutions. And so when we put the plus or minus in front of the square root, that indicates that there's two possible solutions. Notice that this works for equations where you have something squared. So it's going to work for equations that look like this in example 1, where I have an x squared term. If there's also an x term in the equation, then you can't use this type of method. So taking the square root to get rid of the square only works if there's only an x squared for your variable. So we're going to look at example 1. It says to solve 3x squared equals 18. What I need to do first is get x squared by itself. So I'm going to, in this case, to do that, I need to divide both sides by 3. And remember, when you're thinking about solving equations, you're going backwards through order of operations. Undoing the squared is undoing an exponent, which means that you need to undo anything that's added, subtracted, multiplied, or divided first. So I need to get x squared by itself first. Then what I'm going to do to get rid of the squared is take the square root of both sides. And what that does is the square root and the square on this side cancel each other out. And that leaves me with x plus or minus square root of 6. Now you have to remember to add this plus or minus in here. If you don't put that, it's going to be the wrong answer. And you can enter this, I would recommend, in MyMathLab using the plus or minus symbol. But another way that you can write it if you want to is you can do 6, or square root of 6, and then negative square root of 6, and separate them with a comma. That works as well, but I think you're more likely to have a mistake entering it if you try and do it that way. Using the plus or minus symbol is a lot easier, and you can find that along that bottom row that has all the symbols in it. So what you should do next is checkpoint problem number 1. Do this in your notes, check your answer, and then move on with the rest of the video. Next, we're going to look at example 2. 2x squared minus 7 equals 0. So again, I have an x squared in this equation, but I do not have a term that's just x. And that's what allows me to use this method. So what I'm going to do is get x by itself. So I'm going to start by adding 7 to both sides. And then I'm going to divide both sides by 2. Now, it's tempting here to write this as a decimal, 3.5, but MyMathLab is going to want you to keep it as a fraction. And now what I'm going to do is take the square root of both sides to get rid of the squared. So that gives me x equals plus or minus square root of 7 over 2. Now what we're going to use here is what we talked about in section 7.5, rationalizing a denominator. Because if I write this as separate square roots on the top and bottom, then I see that I have a square root in the denominator, and MyMathLab doesn't like that. So I need to rationalize the denominator here in order for my answer in MyMathLab to be marked correct. So rationalize the denominator. Remember, you're multiplying top and bottom by whatever square root is in the denominator. In this case, the denominator is square root of 2. So I'm going to multiply top and bottom by square root of 2. Just keep the plus and minus here. 7 times 2 is 14, so this is square root of 14. And the denominator, 2 times 2 is 4, so the denominator is square root of 4. And then I know that the square root of 4 is 2. So we're going to have plus or minus square root of 14 over 2. No more square root in the denominator, so that should be okay. So that's my answer for example 2. Again, you need to rationalize the denominator or MyMathLab is going to mark it wrong. So next you should try checkpoint problem number 2, another situation where you have to rationalize a denominator. Do this in your notes, check your answer, and then move on with the rest of the video. Next, we're going to look at example 4, and this one looks a little bit different because we have parentheses, and it says solve by the square root property. So what I need to remember about order of operations, parentheses in order of operations comes first. And so that means that when I'm when I'm solving for x, I'm going to undo the parentheses last. So what I'm going to do here is I'm going to get rid of the squared before undoing the parentheses. So what I'm going to do first is take the square root of both sides. That's going to make the squared go away, and I'm going to be left with x minus 1 on the left side. On the right side, I'm going to have plus minus square root of 5. Now, to get x by itself, the last thing that I need to do is add 1 to both sides. So I get x equals positive 1, or just 1, plus minus square root of 5. Now, a habit that you should get into for the problems in this chapter is checking the square root to make sure that it can't be simplified. In this case, my square root is square root of 5. I can't, it's not a perfect square, and I can't divide by anything that is a perfect square, so I don't need to simplify that. But if it were something that needed to be simplified, again in MyMathLab, it would mark it wrong if you didn't simplify it. So next, you should try checkpoint problem number 4. Do this in your notes, check your answer, and then move on with the rest of the video. The last thing that we're going to talk about in this video is the compound interest formula. So we're going to see an application here. And the compound interest formulas, particularly for annual compounding, we're going to see a more general formula a little bit later on in the course. But for annual compounding, compound interest formula looks like this. A equals P times 1 plus R raised to the t power. And so there's a lot of variables here. We're going to go through what they all mean. A is the amount in the account after t years. P is your starting amount, your original amount, or the amount invested. Principal is what P stands for. R is interest rate. And interest rate, when we use any formula involving interest, we always write interest rate or enter interest rate as a decimal. Generally in a problem it's given as a percentage, and so we need to convert to a decimal. And T is time in years. So we're going to look at an example problem, example 9. It says you invested $1,000 in an account whose interest is compounded annually. After T years, the amount or balance in the account is $1,210. Find the annual interest rate. So again, we're using our equation here that we obviously just saw, A equals P, 1 plus R to the T. So I need to identify my variables. Amount in the account is 1,210. Principal or starting amount, initial amount invested is 1,000. Interest rate is what I want to find. So I'm going to leave that as the variable R. And then T is 2 years. So what I'm solving for here is R. So I need to get R by itself. The first thing that I need to do to get R by itself is get rid of this 1,000. So going backwards up through order of operations, I need to get rid of what's multiplied first. So divide both sides by 1,000. This is going to be 1.21. And before getting rid of the parentheses, the second thing I need to get rid of is the exponent, so I need to get rid of the squared, and I do that by taking the square root of both sides. So square root of 1.21, you would do this on your calculator. Now for this problem, like we've seen in other problems involving real-world situations, it would not make sense to have a negative number here equal to 1 plus the interest rate. That would mean I would have an interest rate of less than negative 100%, and that doesn't make any sense. Interest rate here obviously is going to be positive because I'm getting more money. So I'm not going to have a negative interest rate. So I can, I don't need the plus or minus sign here, the negative answer, I can just throw that away. So I have 1.1 equals 1 plus R, and then the last step to getting R by itself is subtract 1 from both sides. That gives me R equals 0.1. Now this is R as a decimal. I want to get R as a percentage. My math lab is going to have you enter the percentage. So to get it as a percentage, you multiply by 100 or move the decimal point 2 places. This is 10%. Kind of a high interest rate, a little bit unrealistic for today's times, but that's okay. So you should next do checkpoint problem number 9. Do this in your notes, check your answer, and then move on to the homework.